We built a time machine, parked it 1 million miles from Earth, and pointed it at the beginning of time. That isn't a metaphor. Because light takes time to travel, looking far enough into space means looking into the past, and the James Webb Space Telescope was built to look further back than anything before it, all the way to the era when the very first galaxies switched on. It started sending pictures home in the summer of 2022. And this is the part almost nobody expected. It didn't just confirm what we thought we would see. It found things our best theories say shouldn't be there, a hint of life we still can't rule out, and a crack in our understanding of the universe that keeps getting wider. So let's walk through what it actually found, because the honest summary is that Webb has raised more questions than it has answered. Which, if you love a good mystery, is the best possible news. First, why this telescope and not the old one? Hubble sees mostly visible light, the light your eyes use. Webb sees infrared, which is heat, and that matters for a strange reason. The universe is expanding, so the light from the most distant, most ancient galaxies gets stretched out on its long journey to us, shifted out of visible light and down into the infrared. To see the first galaxies at all, you have to see in infrared, from somewhere cold and dark, which is why Webb sits 1 million miles out behind a sunshield the size of a tennis court. It is, in the most literal sense, the deepest look into the past we have ever taken. And almost at once, it found a problem. When Webb looked at the early universe, it saw galaxies that were too big, too bright, and too neatly formed, far too soon. A handful appeared to be enormous, up to 100 times more massive than our models said could possibly exist that early. Astronomers started calling them the universe breakers, because in the standard story galaxies build up slowly over billions of years. These looked like fully grown adults in the universe's infancy. Now, science being science, the picture has since become more careful. Some of those distances were overestimated, and some of that light may be coming not from stars, but from giant black holes feeding at the galaxy's hearts. So perhaps the universe isn't broken after all. But at the very least, galaxies grew up far faster than anyone believed they could, and we still can't fully explain how. It keeps breaking records, too. The most distant galaxy Webb has confirmed formed just 290 million years after the Big Bang, an eye blink in cosmic terms, and even that record has since been broken again. And then there's the genuinely strange one. Scattered through the early universe, Webb found hundreds of tiny, intensely red objects that nobody can quite explain. They've been nicknamed the little red dots, and one leading idea is that they're an entirely new kind of thing, a colossal ball of gas larger than our whole solar system, glowing not from nuclear fusion like a star, but from a black hole buried deep inside it. If that turns out to be right, Webb hasn't only found new galaxies. It's found a type of object we didn't know the universe could make. But the discovery that grabbed the biggest headlines wasn't about the distant past at all. It was about a single planet, called K218b, a world roughly 120 light-years away, larger than Earth and wrapped in a thick atmosphere. When Webb studied the starlight filtering through that air, it found methane and carbon dioxide, the kind of chemistry you might expect on a world with an ocean beneath a hydrogen sky. And then came the part everyone seized on. The team reported a faint trace of a molecule called dimethyl sulfide. On Earth, that gas is produced almost entirely by living things, by plankton in the sea. A possible fingerprint of life on another world. Now I have to be straight with you here, because this is exactly where excitement tends to outrun the evidence. That signal is faint, and it is fiercely disputed. Several other teams reanalyzed the very same data and found the trace of that molecule was weak, perhaps not there at all, still perfectly consistent with a lifeless planet. So this is not the discovery of alien life. It's something more delicate and honestly more interesting, a real maybe balanced right at the edge of what our finest instrument can measure, waiting on more data to settle it. And then there's the crack in the foundations, the one I find quietly the most unsettling. There are two different ways to measure how fast the universe is expanding. One reads it from the afterglow of the Big Bang, the universe as it was. The other measures nearby galaxies directly, the universe as it is now. And for years, the two answers have refused to agree. Most people assumed one method simply had a mistake hiding in it. So astronomers used Webb, with its far sharper vision, to check the nearby measurement all over again, and Webb confirmed it. There's no error. The two numbers genuinely don't match. It's called the Hubble tension, and it means something in our standard model of the cosmos, our whole accounting of matter, energy, space, and time, is incomplete. The universe is expanding faster than it has any right to, and nobody yet knows why. So what did the James Webb Telescope find? Not a tidy stack of answers. It found galaxies that grew up too fast, a strange new kind of object glowing in the early dark, a whisper of a molecule that might, or might not, be a sign of life, and hard evidence that our model of the universe is missing something large. We spent decades and $10 billion building the most powerful eye in human history, and what it has shown us, more than anything, is how much we still don't understand. That might sound like a disappointment. It's the opposite. Every one of these puzzles is a door we didn't know was there. The universe, it turns out, is younger looking, stranger, and far more crowded with open questions than our theories ever allowed. The telescope, built to see the beginning, has really shown us something else. The beginning of how much we have left to learn.